Okay. Okay. Good evening, all of you. So welcome to my YouTube channel for mathematics. So today I'll be taking the sixth lecture of solution of triangles, which will be denoted by SOT 6. Okay. So in this lecture we will be covering the last portions of this chapter, which basically includes how to calculate area of a quadrilateral, and there is a theorem called MN theorem, and uh, uh, and in a regular polygon, how do we calculate like in radius and circumradius if we are given um, the length of the side. We are given the length of the side of the polygon. Okay, so starting with the first topic, area of a quadrilateral. Okay, so how do we calculate area of a quadrilateral whose sides are given to us? Okay, so suppose we have a quadrilateral like this, which has four vertices A, B, C, and D. We have this four vertices quadrilateral. The vertices are A, B, C, and D. Okay, so the diagonals will form BD and AC. Okay, so we are interested in finding the area of this quadrilateral. So what we will do here is that suppose this angle is alpha. Okay, this angle is given to us. This angle is alpha. So in that case, this angle will become pi minus alpha. So what I will do here is I will first calculate the area of this triangle ABD. Then I will calculate the area of this triangle BCD, and if I add both the areas, then I will get the area of the quadrilateral ABCD. Okay, so first of all, area of triangle ABD. Okay, so area of triangle ABD, suppose we take the point of intersection of the diagonals to be P. So in this case, area of triangle ABD will be sum of the areas of these two triangles. So for this triangle, the area will be half dp AP into sine of alpha, right? Half dp into AP, product of the two sides, and then sine of the included angle, plus the area of this triangle. So half AP into PB, and then sine of pi minus alpha. Okay, sine of pi minus alpha, because this angle is pi minus alpha here, right? So now we know that sine of pi minus alpha is sine alpha, because in the second quadrant sine is positive, and AP is common and half is also. So AP by 2, and then sine alpha we can take common. In the brackets, what we will get? We will get dp and pb. So if you add these two sides, dp and pb, you get the complete length of the diagonal BD. So we get AP into BD by 2 into sine alpha. Okay, so this is the area of this triangle ABD. Okay, now I need to find the area of the second triangle, which is BCD. Okay, I need to find the area of the second triangle, which is BCD. So area of the second triangle, area of triangle BCD, can be calculated by adding the areas of these two triangles, BCP and PCD. Okay, so this angle is alpha, right? So if I want to find the area of this triangle, half BP into PC into sine alpha, and then add the area of this triangle. So this triangle will be half dp into PC into sine of pi minus alpha. Now again, following the same thing, that in the second quadrant sine is positive. So sine of pi minus alpha will be sine alpha, and PC is common in both the terms and half is common. So we can take PC by 2 into sine alpha common. So we will be left with BP and DP. So BP plus DP. So if you add BP and DP, you get BD. So it will be PC by 2 into BD into sine of alpha. PC by 2 into BD into sine of alpha. Okay, so the area of the first triangle was half AP by 2 into BD into sine of alpha, and for the second triangle, this bigger triangle BCD, we got the expression area as PC by 2 BD into sine alpha. So if you add these two areas, which means basically I am trying to find the area of the quadrilateral ABCD. So ABCD is made up of these two triangles, this triangle and then this triangle. So I am adding the areas of these two triangles. So half AP into BD into sine of alpha, and then area of this triangle, half into PC into BD into sine of alpha. So what you will do, you will take half BD into sine of alpha common, and in brackets you will have AP plus PC. Now if you add AP and PC, you get the complete diagonal AC, right? If you add AP and PC, you get the complete diagonal AC. So half BD into AC into sine of alpha. Okay, so this gives you the proper formula of calculating the area of a quadrilateral. So basically BD and AC are the two diagonals. So we multiply the lengths of the two diagonals and we take sine of the angle between these diagonals. Okay, so this gives us the formula. When you know the lengths of diagonals of a quadrilateral, just multiply them, means take their product, multiply by half, and then multiply by sine of the angle between the two diagonals. That will give you the complete area of the quadrilateral, right? Now continuing ahead, we come to the second topic for today, which is called as MN theorem. Okay, MN theorem denotes that if we have a triangle ABC and I draw a line from A to the opposite side. Suppose that line meets the opposite side BC in the point D, and D divides the opposite side in the ratio m:1, which means the ratio of BD and DC is m:1. This angle we know is theta, this angle is alpha, and this angle is beta. Then from this given information we can conclude two results. M plus n into cot theta is equal to m cot alpha minus n cot beta. Okay, m plus n into cot theta is equal to m cot alpha minus n cot beta, and the second result is m plus n into cot theta is equal to n cot and the second result is m plus n into cot theta is equal to m cot B minus n cot C, right? So this theorem is called as MN theorem. We have a triangle ABC, this angle is alpha, this angle is beta. Sorry, I think in this I made a mistake. It should be m cot C minus n cot B. Yeah, this is correct. These two angles are alpha and beta. Angle BAD is alpha, angle DAC is beta. This information is already given to you. Okay, angle ADC is theta, and we know that this line divides the opposite side in the ratio of in a given ratio, which I have taken as m by n. Okay, so in the question it will be given like it will be either 1:2 or 2:3, something like that. Okay, so from this we can conclude two results. M plus n into cot theta will be equal to m cot alpha minus n cot beta, and second result is m plus n into cot theta is equal to m cot C minus n cot B. Okay, so this theorem is called as MN theorem. Now continuing ahead, we have the third and the final concept of theory which I will be covering in today's lecture, which is that if we have a, how do we like study regular polygon? So basically regular polygon denotes that a polygon which has equal sides and equal angles. Okay, so if suppose we have an n-sided polygon, so like this I can make a diagram. I have an n-sided polygon and I am interested in finding the finding the internal angle, which means this angle. Okay, so this is called an interior angle. So all these interior angles will be equal since this is a regular polygon. Okay, so what I need to do here is that we know that for an n-sided polygon you can form n minus 2 triangles inside the polygon from one point. If you start from one point like this, one triangle, second triangle, third triangle, like this. If you start creating triangles starting from one point, then you can form n minus 2 triangles in an n-sided polygon. So n minus 2 triangles means the sum of all the angles will be n minus 2 into 180 degree. Okay, and if suppose the measure of one angle is theta and we have n angles, okay, so the complete measure will be n into theta because all the interior angles are equal. Okay, and we have one measure as theta and measure of one angle as theta, so sum of all the angles will be n theta. So from this we can calculate the angle of We can calculate the angle, interior angle, measure of an interior angle in a regular polygon by this formula, n minus 2 into 180 degree divided by n. Okay, so in this you have to keep this in mind, that the polygon must be regular, means all the angles and all the sides should be equal. Okay, so this is one thing. And one more thing that I want to find is that how do we calculate in radius and circumradius for an n-sided polygon. Okay, so suppose we have a like cross section like this, okay, and this is the circumcenter. Okay, for a regular polygon, this thing is also important, that incenter and circumcenter are the same point, which means the center of the in circle and the center of the circumcircle both coincide each other in a regular polygon. Okay, so this you need to keep in mind. Now if I join these 2 points, now this will be equal to capital R, because the circumcircle will be passing through the vertices of the polygon. Okay, and now if I join this perpendicular to this will be small r, because the in circle will be touching the sides of the polygon. So the in radius will be the line the perpendicular dropped from the center on the side, that will be equal to in radius, and circumradius will be equal to the line joining the center to the vertex. Okay, and we know the length of this polygon, side of the polygon. Okay, so if we are given the length of side of the polygon, how do we calculate the small r and capital R in terms of A? That is what we are supposed to find. Okay, so the complete we know this angle will be 2 pi by n, because the complete angle is 2 pi and it is getting divided into n parts because of the n sides. So this angle will be 2 pi by n, and now since this is an isosceles triangle, this line will behave as the angle bisector, right? This is an isosceles triangle, so this line will behave angle bisector, which means this angle will be pi by n. This angle will be pi by n, and it will bisect the opposite side. So this length is a by 2 and this length is also a by 2. So now if I apply trigonometry in this triangle, sine of pi by n is equal to perpendicular upon hypotenuse. So a by 2 times capital R, a by 2 upon capital R. So we get capital R like this, a by 2 into sine of pi by n, or in other words you can write like this, a by 2 into cosec of pi by n. Okay, so this is one thing. And then if I want to find small r in terms of a, so small r becomes the base and a by 2 becomes the perpendicular. So what you do, you take cot. So cot of pi by n, in this triangle, if we are applying trigonometry, cot theta, cot of pi by n is base upon perpendicular. So r upon a by 2, which means r will become a by 2 into cot of pi by n, right? R will become a by 2 into cot of pi by n. Okay, so these two things I wanted to find, capital R in terms of a, so capital R is a by 2 into cosec pi by n, and small r in terms of a, so small r is equal to a by 2 into cot pi by n. And last thing is, if we are interested in finding area of the polygon, okay, so if we are interested in finding area of the polygon, now this is a regular polygon, so it means that all these triangles will be congruent. If we take this triangle, another triangle, so all the triangles will be congruent, which means they will have equal area. So what I will do is, I will try to find the area of one triangle and then multiply that by n, because all the triangles are of equal area, right? So n into now area of this triangle. So how do you find area of this triangle? Half, and then small r will become the height, so small r, and then base is a. Okay, so area of this triangle is half base into height, so half base is a, height is small r, so half a into r, and then you have n triangles which will form the complete polygon. So that is why you multiply that by n, right? So n a by 2 into r, and we know the value of r in terms of a. R in terms of a is a by 2 into cot of pi by n. Okay, which means finally what you will get, the result means, I will write the result here. So finally the area of the polygon, you can write n a square by 4 into a will be a square, 2 into 2 will be 4. So n a square by 4 into cot of pi by n. Okay, so this formula gives you the area of the polygon, area of the regular polygon, which is an n-sided polygon. So we know the value of n, and we know the length of side of the polygon, that is a. So if we know n and a, we can find the area of the regular polygon by using this formula. Okay, so this is what was the like remaining portion, which was I took it in the like previous class, but still I wanted to make sure that it's covered in the video, because in the future if you want to revise it, then it should be present. Okay, so with this we complete this chapter called solution of triangles, and then I'll be back with my next video, which will be taking the introduction of vectors. Okay, so for now, thank you all for listening to this video patiently. Okay, thank you.